Hi, everybody. Welcome to week 4. So here are the videos for this week. Actually, maybe just one video. We are talking about ratios, proportions, and rates. So first of all, let's take a look at this week's stuff. As always, your textbook link on the front. If you want extra videos, notes, PowerPoints, and things like that. If you remember, you can click on here and go to the multimedia library of your textbook. And then you have your discussion prompt over here. And the discussion prompt will require you um, to watch a video and then use that video and understanding of effective AI prompting so that you can then use that to do your discussion prompt, because in this one, we're asking you to actually use AI. The idea is that AI is helpful to help us, not to do the work for us, but to help us. And we want to make sure that you know how to use it effectively. So we are incorporating it in this discussion post. But before you use AI to do it, we're asking you to watch this video and then so that you and also read about how to prompt AI and how to use AI before you use it for the discussion post. And then, as always, you have your homework and quiz, which this week has to do with ratios, proportions, and rates. And I am going to actually, give me a second, I forgot to turn my camera on so I can take the notes for you. Just bear with me. Don't like to stop the recording. Things get a little bit confusing that way, so just bear with me. The camera is coming on, and I am going to extend it. There we go. So, fix this. All right. So, ratios, proportions, and rates. Basically, sorry, but I'm still trying to figure this out. Okay. So basically, and I need to add rates. If you think about fractions, fractions show part of a whole. So for example, if you have a pizza and you have 3 pieces and you eat one of the 3 pieces, you write the fraction of the eaten pizza as 1/3, okay? And that is basically showing that this is the part that was eaten out of 3 total wholes, right? This is the whole, the complete thing. Okay, so the top and the bottom both represent the same thing. They represent pizza. Ratios look like proportions, but they actually represent something different. For example, let's say you had a box, and in the box you had 3 pink marbles, and you had 2 blue or green, whichever color it shows up on your screen. So if I want to represent the ratio of if I want to represent the number of green pens to the total of marbles to the total of pens, then that will be a fraction because it's 2 out of total of 5 marbles. But what if I wanted to talk about the compare the number of the greens to the pinks or the pinks to the green? So I have 2 greens to 3 pinks. Okay, so the 2 top, this part right here represent the green marbles. Okay, this one represents the blue marbles. They are not the same thing. They're 2 different things. So it's not a fraction. It's not part of whole. It's 2 quantities, the relationship of 2 quantities together. For that reason, if I ask you what is the ratio of pink to green, this actually would flip over. It would be 3:2 because this is 3 pink ones to 2 green ones. Okay. So that's how ratios are different than fractions, even though we use fractions to represent them. However, ratios can also be represented with the 2 dots, 2:3 or 3:2. We can also write the word 2 So 2 to 3 and 3 to 2. Those are the three different ways that we can represent ratios. Although they are not fractions, they are simplifiable. So for example, let's say instead of 4 pink marbles, we had, I'm sorry, 3, we had 6, right? So then the ratio of green to pink would be 2 to 6, right? And that's simplifiable as we learned in the fraction unit to 1/3, okay? It still represents the ratio of green to pink. It's just in simplified form. So we can, in fact, simplify fractions. Even if they're written like this, and you're asked to simplify it, you know that this is the same thing as this. And you write it like that and simplify it. In fact, I think the first 2 homework questions or quiz questions are asking you to do exactly that, okay? So those are ratios. Now, if we take 2 ratios and set them equal to each other, okay, that will be considered a proportion. So proportion is basically 2 ratios that are equivalent, okay, and set equal to each other. For example, 2/3 and 4/6, okay, as a proportion because those two are equivalent. And if you don't remember from the fraction unit how to decide whether 2 fractions are equivalent, you basically cross multiply, okay? 2 to 6 times 6 is 12, and 3 times 4 is 12. That means these 2 fractions are equivalent, okay? So 2 ratios that are set equal to each other form a proportion. Now, normally we just don't go around and setting ratios equal to each other. We normally use this to find a missing quantity. For example, let's say the question said that I don't know, Jack, whatever, I can't think of a name. Jack makes $36 in 4 hours. And then how much will he get paid if he works 6 hours? So I'm keeping the numbers simple just because I just want to make the point. So not so much worry about calculation. So basically you have 3 values, 3 numbers, right? Okay. Sometimes numbers are not given in numbers. Be careful, they're written in words or given to you in other ways. So you have to be to be careful with that. So basically you're going to set up a proportion. 36 hours in $36 in 4 hours. So that's the ratio, right? The ratio of dollars to hours, 36 to 4. And then how much, we don't know how much, will he get paid if he works 6 hours, okay? There are a couple of ways of doing it. The simplest way is doing cross multiplication, or if it's possible, you can just do it in your head and think about what you would have to either divide this by or multiply them by to get the other number. But that doesn't always work when you have bigger numbers or decimals, right? So the best way to do is by cross multiplication, okay? And here's a shortcut. You're going to multiply the 2 numbers that are across from each other, okay? So 36 times 6, okay? And then you're going to divide whatever that is, okay, by the remaining number. Okay, so multiply the 2 numbers that are across from each other. However, they're across from each other, it doesn't matter. In this case, this is the way they're across from each other. They could have been this and that, okay? So multiply the 2 that are there that you can multiply together, okay? And in this case, let me do it for you. And if you can't do it in your head, that's fine. Use a calculator. So here is a simple calculator. So 36 times 6. And oops, let's try that again. Okay, so 216. And then divide that by the remaining number. So divide 216 by 4, I'm sorry. So by 4 and 54. So what does that mean? If he makes $36 in 4 hours, okay, if he works 6 hours, he's going to make $54. So that's the point of proportions, so that we can find the missing number. So usually if you have a word problem and there are 3 numbers and they're asking you for a 4th number, that's what you're supposed to be doing. That is your clue that you need to set a proportion. Now you have to be very careful when you set the proportion that numbers going across are the same units, right? So in this case, hours and hours, right? I'm sorry, dollars and dollars, hours and hours. You can even flip it over. You can write it like this: in 4 hours, he makes $36. If he works 6 hours, how much does he make? And it would be the same thing, okay? So you would still have, sorry, yeah, let me rewrite this one again. There we go, okay? You would solve it the same thing. You would still multiply the 2 that are across from each other, which you can see 36 times 6, same thing, and then divide it by 4. But going across, the units are the same: hours and hours, dollars and dollars. That should always be the case when you set a proportion. You can mix and match the top and the bottom, okay? This idea of proportion is often used to determine unit rate. Unit rate is how much something costs per 1 unit of something. Think about when you go to grocery stores or a lot of places like hardware stores where you have like carpet, for example, and you see the sign that says $1.29 per square feet or per square yard, or $2 per foot. Okay, that word per, when you see per something, okay, especially for price, that is unit rate. Or another example is speed, 55 miles per hour, right? Or how many gallons of gas your car gets per mile. People talk about how much their car gets, how many miles per gallon, sorry, the other way, gets. So those are unit price of something, or unit amount for 1 unit. So basically, when we are asking for that, we're asking you if you have a total of something, can you tell us what one of that thing would be? Whatever that thing, it could be 1 hour, 1 mile, 1 gallon, whatever, right? So let's go back to the last question. The last question said that Jack made $36 per hour. I'm sorry, in 4 hours. So but we don't know how much he makes per hour. That just means for 4 hours he got $36. So in order to know the unit rate or how much he makes per hour, which is 1 unit, then we're just going to divide that 36 by 4, or you can write it like this, and that gives us 9. That means he makes $9 an hour, okay? Which would have been helpful, if you think about it. It makes sense over here, because if you multiply 9 times 6, you get 54, okay? Right here. Because we got 54 by setting up the proportion, but we already knew that he made $9 an hour. All we needed to do to understand how much he makes in 6 hours, we could multiply 6 times 9, and we get our 54, right? But that's the whole point of proportion. That's how proportions, ratios, and rates are related to each other, okay? So let me show you an example of one of the homework questions you have to do, so that you can see. For example, this one right here is very similar, right? What is the unit rate in dollars per hour if $432 is earned in 36 hours? Very similar to what I did. So let me go back. So 432 and 36. So all you need to do is divide 432. So that's $432 for 36 hours. Well, we don't know how much that is per hour, right? So we are going to basically divide that. So let me go ahead, and you can use a calculator. So 432 divided by 36. So that's $12. So that's $12 an hour. Okay, as simple as that. This is just a division problem. Okay, so let me show you another example of another example of something like, let me see which one I wanted to. Let's do this one. Okay, so it might look very confusing at first, but but it's not. You just have to get your numbers from a table instead of straight from the problem, okay, or written words or whatever. So it says use the following table to determine the ratio of take-home pay to total gross pay. So we're going to look for that. Total gross pay is 255, okay? Take-home pay is 135. Now, the order matters. Ratio of take-home pay to total. So 135 to 255, because that's the order. So 135 to 235. Was it 235? I already forgot. Let me double check. Because my answer will be wrong. 255. Okay, so let me rewrite that. Okay. So you can write it like that, or because we might need to simplify, we're going to write it like this. And it is in fact simplifiable because both of them are divisible by 5. So both 135 and 255 are divisible by 5. So let's divide them. So 135 divided by 5 would be 27. And I'm just using my calculator offline. And 255 divided by 5 is 51. Okay. Now it may look like that we're done, but both of those are actually divisible by 3. So you have to keep trying until you are you can get the simplest form. 27 divided by 3 is 9. Okay, and then 51, and I do some of this in my head, but you guys are welcome to use calculator. 51 divided by 3 is 17. And both 9 and so 17 is a prime number, which means we can't really simplify anymore. So that is your final answer, which means that if you were in math lab, take a look. It says simplify your answer. So if you put that original 135 to 255, it will mark you wrong. So you do need to keep simplifying and use the simplified answer for your homework and quiz questions. So this is pretty much the most important stuff for this week. So this will be the only video. If you have any questions, you know how to reach me.